And welcome back. As we go ahead and continue looking at exceptions, particularly we're going to start analyzing what and how to do throwing an exception when you're within a method. So let's first talk about realistic exception handling. Up to this point, all of our examples of exception handling have been fairly simple or straightforward examples. We have not yet looked at any examples of a program that makes good or realistic uses of exception handling. However, now that we have had that baseline about what exception handling is and how to handle it, we can start moving to more realistic uses or applications of it. Now, this lesson is going to look at the single most important exception handling technique, which is that of throwing an exception within a method and then catching it outside of a method. So, when to actually throw that exception? Sometimes it makes sense to throw an exception in a method, but it doesn't necessarily make sense to catch it within the method. Now, a method with, let's say, code that throws an exception if there's an attempt to divide by 0, very easy example. We may say, you know what, we don't want to catch that exception within that method. We want to handle that differently. So instead, your program's going to use a method that should simply end if that exception is thrown, and maybe other programs would use the method are going to do something else. All right, you're not going to necessarily know what to do with that exception if you caught it within inside of that method. And we're going to look at this with an example. So we look at this with an example. One of the things you're going to start finding is that in these kind of cases, it doesn't make sense to catch that exception within the method definition, but instead to have any program or code that uses the method place that method then within a try block and catch that exception in a catch block that follows that, right? So we're going to look at this more division by 0 example here in just a second. And one of the things you're going to see is that it has a try block, but you'll see there's no throw statement visible within that try block. You're not going to see a throws keyword in there. And when we start looking at those method definitions, you're going to see also that the following statement is doing the following. You have if bottom, which is of course our denominator, is equal to 0, we're going to then throw a new division by 0 exception. This throw statement is not visible within the try block. However, it is in the try block in terms of program execution because it is in the definition of the method safe divide, and there's an invocation safe divide within this try block. And we'll discuss what it means to have that in an upcoming lesson, but let's go ahead and take a look at that code. So here's our more division by 0 class, and you can see we have our try block here. We're getting a numerator, we're getting a denominator. And in both of these, we are, of course, passing in two numbers that we are going to assume are going to be valid numbers for us to use. And so then we, of course, have a quotient that's calculating the numerator and denominator. However, you'll notice that in here, it's calling this method safe divide. It's not just doing numerator divide by denominator. Instead, it's passing it off to a method. And then that method right here, you'll see has this header piece that says throws division by 0 exception. And in here, you'll see it says if the bottom is equal to 0, we throw the exception. So instead of it being here in our main, the biggest thing that we're doing is we're moving those exception handlings off to the methods. And there are advantages of having them off into the methods versus handling it all within our main class. We'll talk about that more as we move on. But one of the things you'll notice is that in this safe divide, of course, and then it runs its program. But if we do throw this a division by 0 exception, you'll see, okay, if it does throw the division by 0 exception, it is caught here, even though that catch is not part of this block of code here. It's not part of the method. It's still part of this try right up here. And this try catch is then going to call this method called second chance, which then, of course, pretty much effectively reruns the whole program all over again. So then it says, hey, I'm going to get a numerator, I'm going to denominator, I'm going to call the method safe divide, and I'm going to attempt to do it again. However, you'll see with this try catch, when it works inside of second chance, is that this one says, I can't do division by 0, aborting program, system.exit 0. So there might still be those times, for example, when you do want your program to terminate, and this is how you can handle that. Whereas up here, you'll see this one simply just calls another method. Again, these are all perfectly valid ways to handle these exceptions. And again, this is another easy example for us to look at because, again, just division by 0. But we're going to use this as a foundation for how we can go ahead and start creating these method headers that are going to make our programs much more robust.